Leader in Visual Presentations, brought to us by Lesson 1.3. Okay, some of the words that we are going to hit today, we're going to continue to talk about solving. We're going to talk about things that are balanced. And like we saw already, we're going to talk about what makes something true. True dat. Okay, flip over to this page. This stuff right here is curriculum that has been placed into your booklet. This is not everything that comes involved with solving equations, but it's some good general knowledge. Okay? You can build off of this and solve things, but I would highly recommend building off of, you have practiced solving equations all the way from middle school up. Algebra 1 and down, you've solved for unknowns. How do you like solving for equations? You guys like solving equations? Negatory. Okay. Oh, she likes negative numbers. No. Okay, so let's talk here. We got equations, like we've said already. This is going to get out of expressions and inequations. Equations equal a statement in which two expressions are equal. So when you throw an equal sign in, we get equations. You've done this for a long time. They're just more complex the farther you go. A linear equation in one variable, an equation that can be written in the form ax equals b, where a and b are constants and it's not equal to 0. You've solved a lot of equations where there's an unknown, just like this. And the solution of an equation is, in a one variable, is a number that when substituted for the variable makes the equation true. So, hey, there are a lot of ways that you might see, depending upon the textbook, depending upon the question, you guys, it might say, find the solution. What unknown makes the equation true? It might even say, what's the answer? What's the answer? It might mean the same thing. There's a lot of synonyms in math. And then equivalent equations are equations that have the same solutions. So let's look at some of these properties. These are real straightforward properties. You might not consider them a property. You might just know this. Like, hey, how many of y'all knew that A equals A? It's called the reflexive property. How many of you flex your arms like this? You look in the mirror, you're like, oh yeah, who's your daddy? When I grew up down at Ninnekah, the best thing that the weight room had was a mirror. It was a really pathetic little weight room, but we were all kind of pipsqueaks down there. When I was growing up, we'd work out a little bit. We thought we were strong, So we'd get to working out. Then we'd go over there in the mirror, like, oh yeah, I got a vein popping out. But when I think of the reflexive property, I think of somebody standing there flexing the right arm, their left arm. But that might always be the case, because not everybody's right arm or left arm are the same strength. How many of you have a stronger dominant arm than the other? Maybe. Raise your hand if you're left-handed. Who's my left-handed people in here?
If I'm using the bow.
We're all right-handed? Okay. Okay, so mostly we can say reflexive. A equals A. Hey, how about this? Did you know that if A equaled B, then B equals A? Did you know that? If A equaled B, then you could also say B equals A. That's the symmetric transitive property. This is the one that you really will think of. A is B. If B is C, then A is C. So if you are the same height as you, and you are the same height as him, then you and him should be the same height. That's what the transitive property says. Additive property, this is when you go to solve. If A equals B, you should be able to add C to both sides and it still be true. Subtraction property, if A equals B, you should be able to subtract C from both sides and it be true. As long, that's the trick in solving equations. What you do to one side, you do to the other. You have to do that. All right, here we go. The multiplication property of A equals B, then you can multiply C to both sides. Division property of A equals B, you should be able to divide C to both sides. And then substitution property of A equals B, then B should be substituted for A in any expression to obtain an equivalent expression. That's true. So little properties, just stuff you might have known already. This right here at the bottom of the page is going to test your ability. Let's see where you're at. Let's see if you can solve for an unknown with kind of a complex equation. And the things we're going to be working with today are going to be complex equations. They're not your simple one-step equations anymore. How many of y'all know how to solve one-step equations? Like subtract 7 from both sides, you have your answer. So today, guys, you're not going to have any of this. X plus 7 equals 10. We're not going to be doing that. Minus 7, there's the subtracted property X equals 3. That's one step solving. We're past that. I'm not telling you that you don't need to still practice that. I'm just saying we're past that. All right, turn the page. We're going to practice this right here. I'm going to put it so you can still see the information. I'm going to stick it right there. Okay, turn the light on. Raise your hand if you have an hourly job. Who works for an hourly wage right now? Anybody? Who plans on getting an hourly job while in high school? A lot of you. Raise your hand if you have a family member that works hourly anywhere. So you're a little bit familiar with hourly.
Extended family?
Yeah. So this says you work 48 hours, and we got our base pay. 40 hours, did you know that typically your first 40 hours you get your base pay? Like, let's say you make 12 bucks an hour, you're gonna get 12 bucks an hour for all those 40 hours. But hey, the next 6 hours, this person is getting time and a half. And then the last 2 hours, they get double time. That's nice. They get a paycheck. They worked their 48-hour a week, and they got $567.10 in a week. Hey, might be okay. Would you take $567 in a week?
Depends on what the job is.
When I was your age, I would definitely take $567 in a week. That's pretty good. Let's see how good it is. I don't know what the hourly wage is. So first thing you're going to do in this situation, we're going to say, this is what my math teacher always drilled in my head, and you guys are sitting there, I want you to say this. I want you to say X equals. We're going to define our unknown. Say it with me. We're going to define our unknown. Our unknown has to represent something. What are we going to have it represent? Who can tell me, what is it we really don't know in this situation?
The amount of money you get each hour?
Yeah, your base pay. Very good. So let's say X is our base pay, like you said, Shine, our hourly wage. We don't know it. We'll figure that out. So now that we know what X represents, now we're going to write an equation. Would y'all agree, using these properties we just looked at, the reflexive property, would you agree that pay equals pay? Would y'all agree with that? Pay equals pay? Yeah. Would you agree that $567.10 equals $567.10? It does, doesn't it? So there is a number that represents their paycheck, and it equals that. What I would like to do is replace one side of this equation, take that number out, and put an expression that could equal that. So I'm going to leave $567.10 over here, but I want an expression over here that represents $567.10. Now I get that expression off of these 3 bullet points, or these 3 arrows. Remember, X is base pay, and I can't just say base pay equals $567.10. This base pay is an hourly wage. Can anybody give me a hint, something I could write?
40.
All right, let's start with 40X. Very good. That's 40 representing the 40 hours at whatever their base pay is. That would be some of the money they made that week. Actually, that's the majority of the money. That took care of that one. But they also work 6 hours, time and a half. Plus, y'all agree, is everybody okay with adding something here?
It would have to be 6y because it can't be 6x.
It-
Otherwise, it would be added into the 40.
It can be more X. How do we say? There we go. Just give the X a little different value. Let's give it a 1.5. That's time and a half. Because if I take it times 1.5, that's 1.5 times. So now we got our 40 hours, we got our 40 hours at just x, 6 hours at 1.5x. Almost there.
And then two parentheses, 2x.
Yes, 2 hours at double the pay. That's a 2x. This expression should equal that. So somebody just with your, let's add this up here. How many x's is that? That's 9. 40x, 6 times 1.5 is 9, times plus 4. Is that 53x? Are y'all okay with that? 53x? I think I'm right there. And if I divide that, x is $10, 10.7. So now come back up here to the top where we defined it and say base pay is actually, label it now, $10.70. Not bad, not the best you can find out there. You know there's kids your age that are making more than that. They are. Doesn't mean you have to, but depends on where you work. That's still not bad. But hey, how many of you guys at your age are going to be able to work 48 hours a week? Not many of you, right? You're a full-time student already. So you're being a full-time student, you can only do part-time work elsewhere at some point. All right, everybody fine with this? So that's a good warm-up. Now turn the page over to this blank area. We're going to continue to look at solving equations. And what we're going to do is I'm going to give you a few examples, some practice questions that you might see. So let's try this one first. Take the equation, example 1, volume, or V equals pi over 3 times r squared times h. Solve it for h. Now this isn't something that you really can't use a calculator for, I don't think. This is just your ability to use your solving techniques. This has V, yes, V equals pi over 3 times r squared times h. We want to get h by itself. Again, we're not finding a solution. We're not actually getting a value. We're just wanting to isolate h. I don't think our calculators do that stuff for us. Okay, let's think about how we get there. What is something I could do to get this h by itself?
Divide by everything else.
That's right. We can divide by everything else. For my brain, will you guys, let's just divide the r squared first. And you'll see why in a minute. So take this side, do this work with me, please. This is you participating. Not a lot to do here, but we're going to divide this r squared. These would go away. And it leaves the pi over 3 in the h. And over here we have the volume over r squared. Now let's see if you've caught on to something here. Why do you think I left the pi over 3 to start?
Oh, because that's already being divided.
And there is a real nice trick I can do to the pi over 3. I want this to be 1h, right? What can I do to pi over 3 to make it 1? Multiply by, you're almost there, multiply by the reciprocal. One of the coolest, sexiest properties out there that we always forget. It's in your tool belt. It's called the inverse property of multiplication. Inverse property. Multiply both sides by the reciprocal. And I like it because it lines everything up on this side. It puts everything in the numerator that should be in the numerator, everything in the denominator that should be in the denominator, and we end up with 3b over pi r squared. This 3 would eliminate, this pi would eliminate, leaving it as 1h. Ain't that a neat property, the inverse property of multiplication? That's some of that algebra stuff that's good to have knowledge of. All right, here's a practice question. 4/9 times x plus 3 equals to g. 4/9 times x plus 3 equals g. So there's two unknowns. We're not going to find the actual solution. Which one do you think I'm going to isolate?
The X.
Yeah, let's isolate the x. I'll give you a couple seconds to see if you can make step one happen. Somebody, if you know what the cool, sexy step one might be.
Don't we do parentheses first, though?
You can, but you don't have to. It's kind of like trying to get yourself from A to B. There's a lot of ways to get from A to B. Sometimes it's nice to know the shortest route from A to B. Multiply by the reciprocal. You remember what we just did up here on this one? If I want to get things away from that x, I like the idea of multiplying using the inverse property multiplication. Multiplying both sides by 9/4. Anybody else like that idea? That's a nice way of going about it.
I have a question.
Yes, ma'am.
What if you, times the 4/9 by X and 3?
Well, we can go there in a second. That's another way, but it's just longer. So let's see what you end up. Let's finish this. 9/4 times g. I'm just going to write it as 9/4 g. You all right with that? What would be the last thing I have to do? Anybody? Yeah, now just subtract the 3. And x is the 9/4 g minus 3. Now, of course, there's other ways. Somebody might want to distribute, even though when you distribute, you're going to incur a few more steps. I'm not real smart, but I'll try it. Y'all help me out. If I had this is the OR approach over here. 4/9 x plus 3 equals g. If I just got rid of the parentheses, I would have 4/9 x plus 12/9 equals g. Y'all agree? Subtract the 12/9. So 4/9 x equals g minus 12/9. Okay? You all right with that? Multiply now by 9/4. Multiply this whole side by 9/4. Okay, Cheyenne? Are we going to get to the same answer, guys? Y'all are smart out there. Are you seeing the same answer happening? This side still equals x. This side, 9/4 times g is what? 9/4 g minus what's 12/9 times 9/4? I believe it's 3, just like we had over there. So yes, you can distribute, then rearrange, or you can multiply by the inverse to start and then subtract. I like this method just because it works in my brain a little bit better. That doesn't mean this might not work in someone else's brain a little bit better. You pick. Okay. Una más, por favor? Ooh, sure. Somebody say chimichanga. I gotta hear chimichanga before I keep going. Somebody say chimichanga. There we go. I like it. I got a good chimichanga. All right, here's another practice. 1/2 times x minus 3 plus 3/2 minus x equals 5x. On this one, there is only one unknown, So let's see if we can solve for x. Very complex. You got x's on both sides. X's are everywhere. Matthew, help me distribute this first one. Tell me what I would have if I would distribute the 1/2.
1/2 x and negative 1.5.
Are you all right if I just leave it as negative 3/2 for now?
Yeah.
Thank you. Can I just drop this parentheses, Zane? Because there's really just a +1. I can't. 1 times 3/2? We're distributing an imaginary 1, or it's not imaginary, but invisible. I said the wrong number. Invisible 1. 1 times negative x, well, everything times 1 is itself. So no more parentheses. This is called the what property of addition? Easton? What property of addition tells me what to do with negative 3/2 plus positive 3/2? They do cancel. That is the identities when you add 0 to something that's still itself. Good try. Inverse. Yeah, the inverse property of addition is when you add opposites, they become nothing. Thank you, inverse property. Nice little tool to whip out and use. Okay, so those disappear. What's 1/2 minus 1? 1/2 minus 1. All right, negative 1/2 x equals 5x. Can somebody tell me already what is the only thing possible that x can be? There's only one number I could put in for x over here and x over here, and it makes the equation true. If I, 5 times negative 3/2 would be a negative 15/2. What do you think?
What about the negative x?
Right, that's 1 minus that became negative 1/2 x. Or 1/2 minus 1 is negative 1/2. I've got this value on this side, I multiply it times 5, and I get the same value on this side, I multiply it times negative 1/2. Think about it. This, what's the only value that it doesn't matter what you multiply it to, it's going to still equal that value? 0, there it was. 1 times 5 would be 5, 1 times negative 1/2 would be negative 1. So, but 0 could be placed here and here, and it still is true. That, whenever I see this situation where it's just a variable and a number and a variable number, that 0 is the only thing it can be. Now, to prove it to you, let's add the 1/2 x, add the 1/2 x. Take it over here, we have 0 equals 5 and 1/2 x. So there we see it again. What is the only thing you can multiply by 5.5 to make 0? That's got to be 0. Let's go ahead and take it farther. Divide by 5 and 1/2. Divide by 5 and 1/2. 0 divided by anything is 0. When is it undefined? It's not when you take 0 divided by anything. It's when you do anything divided by 0 is undefined. Remember that trick? Okay, it was very complex. It's simplified down to the only thing x can be in this scenario is 0. Okay.